friends, welcome back to my channel. I hope everyone is doing well. Today we are going to look into a problem 3248 snake in matrix. So this is another recent problem. So I solved this problem and I wanted to show you the logic and the Java solution how to solve this coding problem. If you are new to this channel, please subscribe to this channel now. It really helps and supports this channel. If you haven't already checked out the playlist, there are more than 500 different varieties of videos solved and explained on this channel. Those includes problems related to BFS, DFS, graphs, matrices, binary search trees, binary trees, as well as different data structures also you can learn here, such as monotonic stack, dynamic programming, memoization, recursion, how to traverse different trees, how to use recursion to traverse graphs, and all other different problems. So do check out those videos. So let's start with the problem statement, then we are going to go through one example so you will completely understand this problem. There is a snake in a n by n matrix grid that can move in 4 possible directions. Each cell in grid is identified by position grid ij, which is equal to I multiplied by n plus j. The snake starts at cell 0 and follows a sequence of commands. Okay, so you are given an integer n representing the size of the grid and array of strings commands where each command is either up, right, down or left. So the snake can go in 4 possible directions, right? It is guaranteed that the snake will remain within the grid boundaries throughout its movement. Return the position of the final cell where the snake ends up executing the command. So we have to execute the commands. The cell 0 0 is where the snake is in the beginning and it will start executing commands. So we have to find out where it will finally land, right? So that's what the problem says. So the constraint says that the n is between 2 and 10 inclusive, and the total commands can be between 100, and the commands are up, right, down and left, and uh, it is guaranteed that the snake will be inside the boundary of a matrix. So n by n matrix will be given to us. So this is an example where you can see that the matrix is 3 by 3 matrix, right? 3 by 3. So this is given to us, and it is also given to us that each cell will have some value here. How will we know the value? Because they have given it here, right? So you can say that the grid ij is equal to I multiplied by n plus j. So this is the value. So it means that basically if you, I'll show you for this 3 by 3 grid. So if you have a 3 by 3 grid like this, right? So the values will start from 0. So it will go like this: 0, 1, 2. So 3, 4, 5, right? 3, 4, 5 and 6, 7, 8. So these are the values for this matrix, right? According to what they said. So the snake will be at the 0, 0, 0 position. So what is this position? This is row 0 and column also 0, right? So 0, 1, 2. So, and this is 0, 1, 2, right? So this is 0. So the snake will start executing the command. So it will first go and execute down command. So it will go down. So it will reach here, right? Down means. Then it will go to right. So it will go here, and then it will go up. It means that it will reach here, right? So finally the value of this cell will be 1. So that's what we want to find out here, right? So what is the value for the last cell after executing the commands? That's what they are asking us to find out, right? But so you understood this problem, what they are asking us clearly. So first thing we will have to do is for the given n by n matrix, we have to populate these values that I shown you here, right? Once we populate these values, then we will simulate the commands, right? How we will simulate? So basically we will simulate like a x direction on this side, right? And this is, let's say, y. So it's kind of a graph, right? So if it goes up, like let's say it goes right side, then you will increment x by 1. So x will be x plus 1 if it is going right, right? If it is going left, right, from the current cell, then your x will be decreased by 1. So it will go to x minus 1, right? So it is left. Up means what? Up means it will be y plus 1, correct? Y plus 1 is up, and down will be y minus 1. So how you treat the y coordinate, right? So so this is how we will simulate these commands. And once all the commands are executed, we already have value for the given grid, so we just have to return the value and it will give us the output, right? So this is how we can approach and solve this problem. So first thing we have to do is populate these values for the given matrix, right? So let me show you the Java code so it will be more easier to explain. So find position of snake is what we are implementing. N is given to us, list of commands are given to us. We will create a n by n grid first. We will create one counter to put the values inside that grid, right? So in these two for loops, we are going to go to each cell, right? Left to right from like this basically. So what we are doing is we are going like this, left to right for each row, right? Each row we are going and we are incrementing, populating value and incrementing the counter. So grid ij is equal to counter plus plus. So these for loops will populate the grid values. Once the grid values are populated, then we have to simulate the commands for the snake, right? So we will put x is equal to 0 and y is equal to 0 in the beginning, because we'll say that the snake is at the 0th cell, correct? This cell is the 0th cell, row is 0, column is 0, right? Now we'll start in this for loop executing the commands. If the command is right, it means that we will increment x. If the command is left, it means that we will increment, we will decrement x. Down means we will increment y and up means we will decrement y, right? Down means increment and up means decrement. So you can choose however you like, right? So down means we are saying it's incrementing here y, and up means you are decrementing the y value. So in this for loop you will start executing those commands and manipulating the value for x and y accordingly, and then at the end you have to just return the grid y comma x will give you the value basically where the snake lands after the end, at the end, right? So this is how you can just solve this problem. So here we are in this code we are saying right means x plus plus and left means x minus minus. Y plus plus means it is going down actually, because we are actually incrementing the row value, right? Here you are incrementing the row value. So y is for the row basically. Y is for the row here, right? Y minus minus is for up direction. Okay, so let's go ahead, run this code and make sure it passes the test cases here. So you can see that the test cases are getting passed here. So this is the example that we just saw, 3 and the commands down, right, up, right? So if you want to create your own test cases also, you can create the own test cases here. So let me refresh the screen and it will I'll show you how to create a test case, right? So let's say you want to add your own test case here, right? So just hold on a second. Right, so you have to just you can just add your test case here, right? So let's say you have a grid which is 4 by 4 grid and you want to execute commands like this one, right? Write down and then uh, write down and then write down, right? So these are your commands. So 4 by 4 grid. So let me remove all this color, so I can just change this grid now, or we can create a 4 by 4 grid here, right? So let's say you have a 4 by 4 grid here, right? And we'll just give a value here. So 0 1 2 3, right? 4 5 6 7. So I just wanted to show you one bigger example. So you can create and how to create your own test cases also, right? You can create your own test cases there to make sure that your code is working with different test cases. So here we are doing write down 3 times, right? You can see that it's write down is coming 3 times. So it means that you will go from here, right here, down, again right, again down, and again right, and again down. So you will reach 15, right? So 15 should be your output basically, correct? So let me try to get the code actually. So I think after I refreshed it, it disappeared. So let me just get my code back. So this is the code that we just saw, right? Okay, So I'll just copy this code. I don't want to rewrite this code again. And then we are going to go and use this code here, and we will run these test cases. So now you will see that I can run my new test case here basically, right? So this is the test case we created and we are getting 15 here, right, which is the correct answer. I just shown you how we came that 15. So you can create your own test cases. That's what I wanted to show you. So let us go ahead, submit this code to the Leetcode, make sure it gets accepted by the Leetcode. And as you can see, the code is accepted here by the Leetcode. Try to resubmit it. Okay, so the code is accepted, but it's showing on this panel actually instead of the left side somehow, I think. Yeah, now it's coming here. So it got accepted almost 90% on the percentile. So this is how you can solve this 30 to 48 snake in matrix problem on Leetcode. So I hope you clearly understood this problem with these examples and the logic and the Java solution for the same. If you are new to this channel, do check out the playlist. There are lots of solved coding problems. More than 500 problems are available here. All important different coding question varieties are covered here, including dynamic programming, memoization, recursion, DFS, BFS, how to use queues, priority queues, min heap, max heap, different varieties of problems related to strings, queues, matrices, monotonic stack as well as stacks. So do check out those. You will also get to learn lots of data structures and programming on this channel as well. If you haven't already subscribed, then do subscribe to this channel right away. It really supports and helps the channel. Share these videos with your friends, colleagues, so they will also learn how to solve different varieties of problems, how to apply and build logic to solve different problems. Keep watching this video, keep your learning going on, and thanks for watching this video and have a great day ahead.